Hello, and welcome to another thing that I made. Bit annoying. I just recorded a 6 minute video or something going over oh, that's the wrong one. I recorded a 6 minute video going over how this worked, and my mic was broken, which is, really satisfying. So instead, I'm going to run through it again and pretend that I don't remember what I said. So let's run it. What I've done is I've made this cool kind of simulation switch that I can go and write simulations in the future. Um, so I've extracted as much as I can from everything. So in the future, all I have to do is write a new Rust file, which controls, for example, linear, controls the position of the ball or whatever I'm doing, and all the movement of the camera in quotes and pausing of time and all that kind of stuff I really don't want to have to keep repeating doing is done for me, um, which is cool. So right now I've got two set up. We've got circular motion, which is just moving on a circle, and then linear motion, which is just some balls moving through space up until a point and then going back down. So well, that's quite satisfying. How have I done this? The first main hurdle was the background. I wanted like a grid background that would change scale and allow me to move around, but I couldn't really think of a way to do it that was efficient and that didn't cause me to draw a bunch of lines, which were just going to slow down the program. So instead, I opted for a shader, but I couldn't use a normal GLSL shader because I'm using Bevy in Rust, and it really likes to use WGSL, which is the web GPU's kind of version of it, which has a bit of nuances and took a lot of time to figure out. So what I'm really doing is going through and getting the real coordinate, which is the UVXY, times with the window size, and a bit of offsetting. And then modulusing or modulusing, I don't know how to pronounce the word, that by a gap factor, which is tied to the zoom, which is why when you zoom out, you get more. When you zoom in, you get less. And then it's got this camera offset, which is technically moving the camera. So when I go to the right here, you would think that the entire kind of background moved. That's kind of intuitive, but that's not really how this works. The way this is working is kind of changing this center point. So the center point where the lines cross is our 0, 0. And when I move it to the right, I'm telling the shader that no, your 0, 0 is not actually in the middle of the screen, it's to the right. And same with these boards here, they are being moved. They're being told, oh, you should just move this far to the right or this far up and down or to the left. So it kind of fakes this look of where it fakes everything really. But it works really well for 2D games, and this is 2D, not really a game, but it's close enough. So how do I write simulations? Now that I've got this background, I want to be able to control the time, and I want to be able to control the position and a bunch of other things. And again, this took a lot longer than I thought it would. In Bevy, you can do something called inserting a resource, and a resource is just a struct, and it's an implementation of that struct, I believe. And you can see we have time here. We have paused, which is useful just to be able to control it. So if I'm having to check did the time move in the last delta, I can just keep track of a Boolean variable, which saves me a bit of time. This 30-line piece of code took a lot of time just to kind of understand what was going on and all that kind of stuff with Bevy, as it was newer to me and it's a newer library. There weren't many examples out there, or there were, I wasn't searching the right things to find them. But now that I had this down, I could go in and start writing some simulations. So the easiest one to kind of go through is linear. If I were to write this from scratch, not using this suite, this would be quite a few times larger because I'd have to do the background, I'd have to do the timing, I'd have to do all that kind of stuff, which I don't want to have to do each time. So what I'm doing is just, spawning some balls. If the state of the game is in linear mode, which is how these buttons kind of change the position. If the state of the game is in linear mode, then spawn the balls. If not, don't. Or despawn them, sorry. And then we have this scale ball function, which is a function which uses that grid kind of query. So we have that grid shader, and we are getting the default zoom and the zoom from that, and doing a bit of maths to figure out how big that ball should actually be with respect to its initial position. So this is like a function that you would use in all the simulations. So this is like a copy pasta. In circular, you can see it's the exact same function, maybe slight tweaks to how it's done because I may not spawn a ball, I may spawn something else, but in essence, this is abstracted for me. Yes, I have to copy and paste it, and yes, there's probably a much smarter way of doing it, which I don't know yet, but it's abstracted. I can just put it in and trust that it'll do what I think it should do. And then we have this move ball function, which is called in every frame. And this is where kind of the magic happens. This is where it gets the camera offset and again the zoom to figure out that camera offset and applies that to a transform, which moves it to a position. And I found that the best way to figure out the position was not to add something on, as I initially thought. It was to use some sort of mathematical equation to define strictly where it should be at that time step, which is why it's so important that we have this time and why it means that these positions are linked. If I keep going through, when this hits 0, they're in essentially their initial starting position. So how did I do it with linear? Well, I found the best way to do it was to use a triangular wave. If you don't know much about waves of functions, it's a really easy kind of thing to understand. It's a triangle. It means that within one time step, so you can see at the bottom here, 1 second, that's our period, it is moved up and then down. It's done a linear up and a linear down, which is this equation here, 2 times the yada yada yada, you can Google it. And what we're kind of doing is we're going through and saying, okay, let this difference vector be the start to the end position, so from A to B. And then we add onto the start position the difference times by that number, that vector from 0 to 1. So if you imagine that this here is a period from 0 to 1, then you can imagine, or like start to whatever period, let's say 1 second. You can imagine this y-axis is the amount through that interpolation from start to end position you are. So you can see it goes up, it hits a peak linearly, and it goes down. Which is how when you run it, it goes up to a peak, snaps back down, and then goes back to its initial peak. If we were to change this to a sine wave, it would be more smooth and it would be a bit more flowy, and we can use different kinds of functions to make it go fast and then slow down and all that kind of cool stuff. If we use a sawtooth wave, which was my initial thought, it would just go up to here, to that max position, and then snap back to the start, and then reset the entire thing. So there would be no kind of backwards momentum. And it's the exact same with circular motion. There's no real physics in it. It's just kind of using a circular equation, circular motion equation to figure out where it should be based on the time variable. This is slightly old. As you can see, my initial thought was to add on to the position. But yeah, it doesn't work as well as just strictly defining it based off an equation. So yeah, it's kind of cool. Can't wait to add more stuff. Don't know what I'd add, but it's nice to have a suite where I can just tinker around with something that comes into my head, so I can refresh my brain on whatever thing I'm learning at that time. So yeah, cool.